Hi, everyone. So I wanted to get on here to go over greatest common factor. So we're going to look at it two different ways today. We're going to look at it with factor rainbows, which is going to break it down into numbers that we can multiply together to get the number. Or we are going to look at it as a prime factorization tree. So let's look at an example. So let's start with 12 and 30. So I want to know what my greatest common factor for 12 and 30 is. So to do this using factor rainbows. To start, I'm always going to do the obvious factor, and every number can be divided by 1. So you are looking for numbers that you can divide 12 by and get a whole number as the quotient. So if I divide 12 by 1, I get 12. So we are going to try to form a rainbow, or if we connect our factors, by listing our factors from least to greatest. And we're only going to list each factor one time. So I don't need to list 1, 12 again. It's only a factor pair once. The second factor pair, can I divide 12 by 2 and get a whole number? You can. So it is a factor. So it's 2 and 6. Can I divide 12 by 3 and get a whole number? Yes. So it's 3 and 4. I have no other whole numbers between 3 and 4, so I know I'm done. And 12 has 6 factors in 3 factor pairs. So now I'm going to go down to 30. So can I divide 30 by 1? Yes, you can divide any number by 1. So I know I'm always going to start with 1 and the number. Then I need to ask myself, can I divide 30 by 2? Yes, and it's a whole number. It's 15. So 2, 15. I need to ask myself the next number. Can I divide 30 by 3? You can, and it's 10. Can I divide 30 by 4 and get a whole number? No, you can't. So then I need to move on. So can I divide it by 5? Yes. So it's 5 and 6. I have no other whole numbers between 5 and 6, so I know that they're done. So we are looking for the greatest common factor. So if we look at that term, greatest, that means largest, common, they both share it. And a factor is a number that I can divide both numbers by and get a whole number. So I'm going to start on the end because I want the largest number, and I'm going to compare them until I find something that they have similar. 12 is not down here, so it's not a common factor. 6. I have a 6 down here. So that is going to be our answer. So the greatest common factor of 12 and 30 is going to be 6. They do share other factors. They share 3, a 2, and a 1, but it's not the greatest, so it's not the answer. We only have one answer, and it's the number that they both share that's the largest. So that is factor rainbows. Let's look at this now and see if we can get the same answer by using prime factorization trees. So prime factorization trees mean that I am going to be looking for all the factors that multiply together to get to 12 and 30. I should be able to get it down to where there are no composite numbers. So a prime number means that the only factors are one in itself. And then a composite means that it has multiple factors besides just one in itself. Okay, so 12 and 30 are both composite numbers. So I'm going to do prime factorization trees. So I start with 12. I am looking for 2 factors that I can multiply together to get to 12. So let's start with 3 and 4. So I have 3 and I have 4. Sorry. There we go. I need to ask myself, is either of those prime? Yes, 3 is prime because the only numbers I can multiply together that are whole numbers to get to 3 are 1 and 3. So that's prime. So I'm going to circle that because that's going to be needed later. 4 is composite because I am going to be multiplying 2 times 2 to get it. So I'm going to do branches off. 2 times 2 is 2 prime. It is. So the only two whole numbers that I can use is 1 and 2. So that's prime. So I'm going to go ahead and circle those. All of my lines end with circles. So I know that I'm done. And my prime factorization for this is 2 times 2 times 3. I want to list it from least to greatest. I'm going to do the same thing with 30. And I'm going to find two numbers I can multiply together to get to 30. So I like 5 and 6. 5 is prime, 6 is composite. So I'm going to circle the 5 because I know that that's prime. 6 is composite, so I know I can have two numbers to multiply together, and that is going to be 2 and 3. I need to determine is 2 and 3, are either of them or both of them prime? And they're both prime, so I'm going to circle both of them. So I am going to now list these prime numbers in order from least to greatest. So 2 times 3 times 5. So now I have both sets of prime factors. So 2 times 2 times 3 will give me 12. 2 times 3 times 5 will get me 30. So what I'm going to do is I am going to stack these two sets of numbers on top of each other. It doesn't matter. They both have 3 numbers. It doesn't matter which one goes on top, but typically I put the one whoever has the most digits on top. So if one of them had 4 prime numbers, I would put that on top of the other one. So 2 times 2 times 3, 2 times 3 times 5. With greatest common factor, I am looking for vertical pairs to figure out what numbers do they both share. And I'm going to circle when I come to a vertical pair. So I have a 2 here and a 2 here. So I'm going to circle both of those 2s. I cannot match this 2 with the other 2 on the top line because it's already in a pair and I can only use it once. So now I'm going to look for another vertical pair. And I have a 3 on the bottom line and I have a 3 on top. They do not have to stack on top of each other for them to be vertical pairs. So I'm going to use both of these 3s. I do not have a top 5. I only have one on the bottom, and I do not have another 2 on the bottom, so I'm only going to use it once. I'm going to bring one of each of these numbers down. So I'm going to bring a 1, 2, and I'm going to bring 1, 3. I'm going to multiply them together and get 6. So as you can see, we got the same answer using prime factorization trees and using factor rainbows. So either one will get you the same answer. It's whatever you prefer. So if you have any questions, please let me know. And I hope you guys have a great day. Bye.